Hi, my name is Rohit. Today we'll talk about Spring Core. But before we talk about Spring Core, we'll talk about two design patterns, inversion of control and dependency injection. Both these patterns, short forms IoC and DI, are there to help us decouple code. Now instead of going into theory of this, we'll take a problem statement and apply the above patterns to understand how best they can be used. Here's a use case where I have a class called as expression evaluator. This class can take a string expression, in this case mentioned as 3 into 4 plus sine of cos of 30, and give out an output like 12.1536448. A simple example would be 2 plus 2 as an input and output being 4. So the whole case is that we want to test this class with expressions. So we want to create a test framework to test this particular module. In order to test it thoroughly, what we will do is we'll have 10,000 inputs with different kinds of expressions, boundary cases, in various permutations and combinations, and we'll run them through the expression evaluator to see how best it performs. So this is a use case. Create a test framework to test expression evaluator with 10,000 expressions. Given that any developer or QA would begin to solve this problem, they would end up with code like this, where you have a method in which you're doing a for loop on all the input files, getting the actual expression, getting the actual expected result, and then getting an instance of the evaluator and calling evaluate on that. This is where we actually execute the code and the test. At the end, we compare the expected result with the actual result and decide whether things have passed or failed. Now what's wrong with this code? A lot of things. This is a single class with many responsibilities like iterating, getting the data, evaluating the test, publishing the results, and everything. A good design would be when each class has a single role. This helps us create different modules, and the modules can be reused. Now we have known what's wrong with this code, let's jump forward to see what's a good way of coding this. These are all the interfaces which you want to define for the above things. In this case, we have broken down the earlier code into different interfaces and classes. Foremost important thing is a test case interface, which takes a test data as an input, which is a generic, and returns back a result, which is again a generic. So I can pass a string, get back a string, I can pass a string, get back a long, or I can basically pass a data structure and get back a data structure. So this is the class which abstracts the module and the test. Then we have a test executioner which loops over all the input data and it calls test case n number of times. So let's say for 10,000 inputs, I'll call a test case 10,000 number of times. But wait, I need the test data. The test data could be coming from a CSV file, XML file, database, web service, anything else. I need an adapter to adapt to that. This is one of the adapters to adapt to that. In this case, I've got an adapter which just gives me a method called as get input. Given the index, it will get me the data at a particular index. Again, this uses generics, so it could be anything. Similarly, I also need to know what do I expect when I run the input data to the test case. This is the expected result. Like input data, this is also an adapter to your system which gives me the expected result. This could be a CSV XML, or it could actually be a live database in production where we are going and fetching what's exactly happening. At the same time, when we run this whole test case 10,000 number of times, we want to know what's going on. So we'll talk about a publisher. Publisher is something which can publish this result. It may publish it to a console, an XML file, a server, database, whatever it is. So similarly, we require a logger, which is used by a number of components. The logger is also defined with an interface. Notice the outgoing arrows from test executioner. This means the test executioner is dependent on input data, expected result, test case, logger, and publisher. All these are couplings. And these have strong couplings if test executioner is saying new input data, new expected result, new test case, new logger, new publisher. Wherever you use new, you're tying down that particular class to a particular implementation of an interface, which is a strong coupling. This is what is bad. We want to avoid this, and let's see a way of avoiding this. The whole technique of avoiding this is what dependency injection and inversion of control is all about. Now imagine this: instead of the text executioner class saying new logger, test case, input adapter, output adapter, result publisher in its constructor and having a strong coupling, we say that we have a setter method for each of these dependencies. And some other party from outside will actually set proper logger, test case, input adapter, output adapter, result publisher on test executioner, and then the test executioner begins to do execute. This is what we call as dependency injection. We are injecting the dependency, which is the logger, test case, and input adapter, etc., inside test executioner. At the same time, this is inversion of control. The control is gone to something else, which controls what kind of dependencies are being injected in test executioner. Now enough of going to slides. Let's see this in code. This is an Eclipse project where I have various number of interfaces defined in this package. I will start by test case. Notice I'm using a convention where I is a prefix to all the interfaces. So in this case, this has two generic components called as D and R. So test case takes a data and results the result. So it can take a string as a data, which could be an expression, and return a value, which can again be a string or a double or something else. In this case, we'll assume them both to be strings. So this is how we declare a contract for test case. Now test case requires input data. The input data adapter interface also uses generics to get us the input data. It first of all provides us the count of how many number of input data is there, and then it provides a method to get a particular input data at the particular row. Again, use of generics. This could be string. Similarly, we require the expected data. So we have the expected data adapter. This is very similar to input data, input adapter. Then we require a publisher. A publisher is the one who is publishing the test results outside. We are having a lifecycle where we say init, so where you can initialize a database connection, or initialize writing to a file, or initialize opening a connection with the server. Then we have a collect method where we are passing everything: the input data, the output data, and the data which we expected. And finally, a publish methods to actually publish things live. So we can expect input to be called once, collect to be called number of times, and publish to be called once. While we are saying this, let's look at this test executioner. It has a method called as execute. This is called test executioner 1 because this is a variant of the actual test executioner. I'll show in a while why. So let's assume that we only have execute method over here. Let's go to the mock implementation. So if I go to the mock implementation, I'll give a bad example of executioner. In this case, I'm saying new for every interface over here. So I'm coupling strongly with that particular implementation. So this particular implementation depends on other implementation of the interfaces it depends on, which is bad. Tomorrow, if I want to change a dependency on some other component, I will have to change the code. So because I've done this, I got everything in place which I wanted. Then I'm saying execute. In the execute, I'm initializing the publisher. I'm setting a particular lock level. I'm going through 100 data, and I'm basically going through the input adapter, getting the expression, getting the actual result by executing the test case, getting the expected result, seeing what is the result, publishing it to the publisher, and closing the publisher. Very simple. There's a launcher for this over here, which looks like this. So I'm saying test executioner 1, executioner is equal to bad executioner. Once I run this, you'll see the result as this. This happens because the mock publisher has a system out.println over here, which is called over here. Now this is coupling. Let's look at an example where I can remove this coupling. So I changed the ITest executioner to have the same public void execute method, but then I add methods for setter and getter for each dependency it has. So you can see the set methods. Then I'll go to an example of mock executioner. In this case, I only have the interfaces defined over there. There are no new mentioned over here. There's no dependency outside, and everything is injected using the set methods over here. And lastly, the execute method is actually the same. Let's look at a decouple main example. In a decouple main example, what I'm doing is I'm creating an instance of the executioner, and then I'm telling the executioner that you need to use new mock publisher, new test state, mock test state adapter, things like that. But it's a main class which is doing this dependency injection. So let's run this. It runs in the same manner. So the outcome is just the same. The advantage is that the executioner function, the mock executioner, doesn't have any new, which is a good thing. Let's go to a production environment. The production environment is declared under the production package. Here, if I look at a class which is called as math evaluator, this is a class which is under test. This is a class which is from internet, from a guy named Isenlea. He has written a good example of how to do math evaluation, and he supports all these operators in his evaluation. So I create a math evaluator test case which implements ITest case. Look at the user generics. I'm saying string. I'm evaluating the expression, and then I'm getting the value and converting it to string and passing it back. I'm actually using a CSV class to provide the inputs. So I'm using a single CSV class to say this is the expression and this is the output. So left is the expression, right is the output. Then I have this test data adapter which implements both input adapter and expected data adapter. It goes to the given file name and populates test data, which is a list of test data. Test data has two components, input data and expected output. So this is the interface. Then I have a discount and get expected and get input as the method which I implemented. Then I'll go to CSV publisher. The CSV publisher class, we are injecting the logger into this, and we are also injecting the file prefix. The file prefix is used to put in the name of the file. We'll just see it in a moment. And then the collect and the publish method are used to write to the file and close the file. So we're writing to a particular CSV file. The console logger is a simple thing which has a set level method where you set the log level. The log levels could be info, debug, and error. And when we print, it just prints a log level and a message. Obviously, it prints a log if the log level is above a particular mention level. Then let's go to actual executioner. Again, in the actual executioner, we're just declaring the interface. We're not saying new for the implementation. And at the end, we got a similar thing. Here there's a thing missing which is called as console logger.set log level. We are doing it somewhere else. So this is actual executioner. This is a production main. Again, the same thing happening. I'm having the executioner, and the main is the one who is basically injecting the dependency. Let's run this.